Okay, students, so welcome to 2.3, and this is the sine law. So here are the learning outcomes. So these are all the things you need to be able to do from this chapter. Now, you have previously encountered problems involving right triangles. Just got to check my mic is on. Perfect. You have previously encountered problems involving right triangles that you could solve using the Pythagorean theorem and primary trig ratios. So this is talking about Math 10C here. So remember, you can only use tan angle equals opposite over adjacent, cosangle equals adjacent over hypotenuse, and sine angle equals opposite over hypotenuse. You can only use these if you're dealing with a right triangle. So a triangle that has a 90-degree angle. As soon as you have a triangle that does not have that, you cannot use it. Similar to Pythagorean theorem. So a squared plus b squared equals c squared. That requires a right triangle. Now, what happens when we have interesting problems that involve oblique triangles? So oblique triangles are any triangle that do not contain a right angle. Okay, so they don't have a 90-degree angle. Well, that's what we're going to learn today. So we are going to learn these sine ratios. So these are found right here on your data sheet. These are your sine ratios or sine laws. Okay, and they're not too bad to use, and they're pretty cool on how they work. So the ratios of sine A over A equals sine B over B equals sine C over C are equivalent for all three side angle pairs in any oblique triangle. It's actually true for any triangle, really. So here's an acute triangle. And we can now use our sine laws. Now, how does it work? We need to know how to set this up properly in order to use them. So the way it works, let's just derive, is often we notate the corners or the vertices of a triangle as ABC. So just recognize that these are triangles A, C, B. Okay, this is a triangle formed by the vertex A, C, and B. Now, here, we usually use capital letters to notate the angles, and we usually use lowercase letters to notate the legs. Now, recognize that we have the angles notated as the capital letter of the opposing leg. So here's angle B, and it is opposite to little b. Here is angle C, and it is opposite to little c. Here is angle A, and it is opposite to little a. So you want to get used to always notating it like this. Because the neat thing about your sine law is the fact that if we take sine C, so capital C, which is our angle, and we put that over C, so our leg, this is equal to sine A over little a. Sine A over little a. And it's also true if we take sine B and put it over little b. So we have this really neat set of rules. You can also inverse this. Little c over sine C equals little a over sine A equals little b over sine B. So some really neat, useful laws in order to solve non-right angle triangles. Something else I want you to recall and remember is that this is true for all triangles. All triangle angles add up to 180 degrees. So angle A plus angle B plus angle C equals 180 degrees. I also just want to notate a few other things here on sine conventions. This angle A could also be represented as angle CAB. This notation is the angle created by the legs CA and B. Sorry, this should actually be, CA and B. So if we look here, the vertices CA and B create angle A, plus angle ABC. Vertices ABC create angle B, plus angle BCA. Here we can see that angle BCA forms angle C. So just some review of a little bit of notation here. But this is a very important rule moving forward. So let's go use our sine laws in a few examples. Bring along our equation here. So let's prove it, first of all. So it's really useful to prove things in order instead of just kind of accepting them. So for the acute triangle, prove the sine law. Okay. So in this case, what are we dealing with? Well, let's notate a few things. This here, L and N, we're going to notate that as little n because it's the opposite here. This side length L to M is going to be notated as little n, and from here, M to N, that will be L. So little l. So now we have some angles here. Now recognize they have dropped us a height in this case. The height here will help us solve the sine law. Okay, so essentially help us create a ratio for the sine law. So how are we going to do this? Well, what we're going to do is we're going to focus on these true triangles here. So I'm going to put a point here. I'm going to notate this point as X. Okay. So we have two right triangles. We have a right triangle that's formed by L, X, and N. Okay. Where this is the height here and this is little m here. Then I have another triangle formed by M, capital L, and X. So that's this triangle here. And again, this is 90 degrees here, this would be 90 degrees, and here is your height. So we want to relate the height to our ratios, or our sine angles here. So in this case, this is the length n, and this is the length m. So what I'm going to do is I'm going to focus on this angle, and I'm going to focus on this angle. So I'm kind of jumping between the two triangles that we're dealing with here. Now, this is angle M. This is angle N. So angle N, let's make it a capital M, angle M, and angle N. Let's talk about the sine ratios of these things. So sine angle M, so I'll put little angle M here. Well, let's just notate it as capital M. There we go, sine M. Remember what sine is. Sine angle equals so opposite over hypotenuse. So what's the opposite leg? Because this is a right triangle we can deal with. It's height. So this is the height. Sorry, not quite. The opposite leg here is the height. And then our hypotenuse is little n. So there's n there. Over here, let's talk about the sine angle of n. Again, opposite over hypotenuse. What's the opposite leg? It is h. What is the hypotenuse? It's little m in this case. So now for both, let's solve for h. So in this case, I'm going to multiply both sides by n to cancel out my n. And now I have n times sine m equals h. I'm going to do a similar thing over here and solve for h. I'm going to multiply it by m, and we can see that m times sine n equals h. And now recognize you have two h values that equate to one another. So that means these two actually equal each other. So if h equals h, we have n sine m equaling m sine n. And now hopefully we can see here that we can make this true. If I divide both sides by n, what do I end up getting? I get sine m equals m sine n over n. And now, if I divide by m here, I have sine m over m equals sine big N over n. And there is a proof of our sine law. So we have proved that the angle m and its opposing leg is equal to another angle in the triangle and its opposing leg. So here we have angle m and little m. That ratio here is equal to n, big N, the angle, over little n. So there is a quick little proof of your sine ratios, which is pretty neat. So that's how a sine law works. It's useful to just know where that comes from. So let's look at example 2 here and solve this one. So sketch a triangle that corresponds to the equation below. Then solve for the unknown side length or angle measure. Round the nearest one decimal place. So recognize this won't be in your note package. I had to write it out. For some reason, the PDF did not decide to work with me on that one. So make sure you write this out. This is the equation that's given. So 7 times sine 40 equals x times sine 30. So what can we do here? What we can do is rearrange this. So I'm going to divide both sides by 7, and I'm going to get sine 40 equals x sine 30 over 7. And then I'm going to divide both sides by x. And I will get sine 40 over x equals sine 30 over 7. And now hopefully we can see we're dealing with a ratio here. So looks like, just give me one sec, gotta move all this over. So there we go. Okay, so we can bring this down here so we can work with it. Just gonna quickly move this back. So now in this point, what are we dealing with? Well, we can create a triangle based off this information. We have an angle within sine, an x, which is a side length. We have an angle within sine, and we have a leg of b. So let's draw just an arbitrary looking triangle. It can kind of look like any sort of triangle here. That triangle looks a little too perfect. Let's make it a little bit more unique. There we go, as long as it's not 90 degrees. Now let's place our angle here. So this is 40 degrees. And the opposing side length of 40 would be x. So this is going to be x up here. Then we can either make this 30 or this 30. It doesn't really matter. Let's make this side length 30 here. Meaning that our opposing side length of 30 would be 7. So that's how our ratios work. And now at this point, you have the triangle all set up. Let's maybe notate these. So since this is x, I'm going to make this capital X because it's the opposing angle. Over here, let's make this P. Actually, that's hard to tell. Let's make this Q, and this would be little q. And finally, let's make this capital D. So this would be little d. So now we have notated and labeled our triangle. So now we can work with this pretty easy. Here it's a matter of just solving for x. So using a bit of algebra. So to find for that unknown side length, we're going to solve for x. So let's rewrite this. Sine 40 over x equals sine 30 over 7. So my first thing I'm going to do is I'm going to multiply both sides by x. So that cancels out this x. And we get sine 40 equals x times sine 30 over 7. And now I'm solving for what x is. So the reason I multiplied x by both sides is to get x on top, because you don't want to deal with your variable you're solving for in the denominator. And now it's a matter of solving for x. So here 7 is dividing, so I'm going to multiply both sides by 7. So I get 7 times sine 40 equals sine 30. Let's put x sine 30. So these canceled out. And now I can divide sine 30. And now I have the ability to plug this into my calculator. So x equals 7 times sine 40 over sine 30. And let's check what that becomes. So 7 times sine 40 dividing sine 30. And that gives me 8.999. So this will give me 8.999. And what did it want us to round to? It wants us to round to the nearest one decimal place. So it wants us to round to the nearest decimal place. So this 9 here will round this up. So that's actually going to end up rounding this up. So this will equal 9.0. So it looks like we found our side length of x, 9.0. Now, let's just add on to this question. Although we have figured out the unknown side length, we could actually solve this triangle fully. Why could we solve this triangle fully? Because we could actually find d fairly easily with our sine laws. All you have to have is the opposing angle. How do we find the opposing angle? Well, we can remember that all angles in a triangle add up to 180 degrees. So I could find angle D here. Angle D would equal 180 minus 40 minus 30. So we could plug that into our calculator here. 180 minus 40 minus 30. That gives me 110 degrees. So here, this is 110 degrees. And now you can use your sine law again. I would probably use the one that I did not round. So I would use the fact that sine 30 over 7 equals sine 110 over d. Or, to make my life easier, since I'm solving for a side length, I would probably put the side lengths on the top here. So I'm solving for d. So I'm just going to do this up here. D over sine d equals, and again, I'm going to use the non-rounded values. So I'm going to use 7 here. Equals q over sine q. And now you can plug in those values. So d over sine d, which was sine 110, equals q, which is 7, over sine 30. And we have the ability to solve for d. So d will equal, let's get a skinnier pen here, 7 times sine 110 over sine 30. And now we have the ability to know what d is. So I multiplied both sides here by sine 110. So I multiplied this side by sine 110, this side by sine 110, and it canceled out sine 110 over here, giving me my solution. So 7 times sine 110 dividing sine 30. And I get a side length of 13.15. We're going to round to the nearest decimal place, so it's 13.2. So D equals 13.2. So we've actually solved this entire triangle now using our sine ratios twice, or our sine laws. So stop there. I would maybe give example 1 a shot on your own. See if you're able to do it, and check after the video if you got it correct. I will work through it. Let's work through example 1 here. It says, determine the length of B to the nearest tenth of a centimeter. So again, when we look at this leg is opposite to this angle. This leg is opposite to this angle. And this leg is opposite to this angle. So this shouldn't actually be too hard. Here, it's actually listed A, B, C very nicely for us. Understand that since this angle is opposite to this leg, I'm going to notate this as C. And now from here, this shouldn't be too bad. I'm solving for leg B. So since I'm solving for leg B, what does that mean I'm going to do? I'm solving for a leg, so I'm going to put my leg values on the numerator's position. So I don't have to do some kind of annoying algebra. So here, sine B is going to be, or sorry, leg B is over sine big B. And now, what angle do I know that has the given opposing side length? Well, that's angle C and length C. So this will be C over sine C. And now at this point, it's a matter of plugging in. So B is what I'm solving for. Sine B, angle B is 72. So sine 72. And that's going to equal little c, which is 27.2, over sine c, which is 43. And now we can see we have enough information to solve for B. I'm solving for B. Sine 72 is dividing B, so I'm going to multiply both sides by sine 72. It's going to cancel that out. And we will get B equaling 27.2 times sine 72 over sine 43. And this is going to give us 27.2 times sine 72 dividing sine 43. And here we can see that B will equal 37.93. And let's check what our question asked us to round to. Rounds us to the nearest tenth of a centimeter. So since the number here to the right of our tenth is not greater than 5 or greater, I'm going to leave it as 9. So B equals 37.9 centimeters. And there's your solution. Now ask yourself, would you be able to find this side length B to C? You absolutely could. You do what we did above. Find this angle, repeat. So if you want to practice, definitely try and find B to C here. If you have any questions on this question, please come ask. But we are going to move on to example 2. So for example 2, it wants us now to determine the degree. So it's always good to choose whether I'm going to put my angles on the top or my side lengths on the top. If you're solving for angles, put the angles on the top. If you're solving for a side length, put the side length on the top. So here again, they have notated it as ABC nicely for us, but that's not always going to be the case. Sometimes they'll be notated in different values or letters. And if that's true, I would honestly suggest switching the letters to A, B, and C, just because it's way easier to deal with. So this is angle B, making the opposite leg to it, little b. This is angle C, what we're solving for, and that's opposite to little c. We're trying to solve for angle C. So in this case, sine C is going to go on the top, and the ratio on the bottom should be the opposing side length, 37.1 centimeters. This is going to equal, find the angle given that has the opposing leg given. So this will be sine B which is 44, over 29.5 centimeters. Now I realize I never actually listed down this in terms of just its variables. So what I've done here is I've done sine C over little c, and I've done sine B over little b. So I set up these ratios, which we can be found over here. So now at this point, it's a matter of just solving for it correctly. So I'm first going to multiply 37.1 by both sides. And that's going to give me sine C equaling sine 44 times 37.1 over 29.5. So let's first figure out what that is. So sine 44 times 37.1 dividing 29.5. So that gives us 0.873621249. Now I've just found the ratio. This is not the angle, okay? So it's something to understand. That's not the angle, that's the ratio. In order to find the angle of C, we are going to take the inverse of this ratio. 0.873621202. Oops. 212049, and we will get the, so I'm going to press second sine. Now I want this answer that we just used, so this is a little trick. If you press second and you find the little ants in your calculator, that ants is the previous answer you just got. So that will be 60.88 degrees, and let's check what nearest degree this wants. It wants it to the nearest degree. So I'm just going to round it to 61 degrees. So there is angle C. Now remember, we could technically solve for angle A. Angle A would be 180 minus 44 minus 61. And then you could use this trig ratios or the sine laws to solve it, leg B to C. So I hope that was helpful. And I hope that made sense. If you have any questions or you felt confused at any point, please come in and chat. Now, let's move to our very last example here for the sine laws. So our last example, we have Mr. S uses chains attached to hooks on the ceiling and a winch to lift engines at his buddy's garage. The chains, the winch, and the ceiling are arranged as shown below. So determine the angles. So here it wants us to find all the angles. Notice it gives us all the side lengths here. And now we're just dealing with a triangle. So I'm going to simplify this a little bit, and I'm going to just make it a really easy triangle to understand. So this is 86 degrees. This is theta. Here, this is known as alpha. We know the side length here to be 2.8 meters. We know the side length here to be 1.9 meters. And we know the side length here to be 2.2 meters. And now, hopefully we can see what to do. We're solving for these angles. The first thing I'm going to do is I'm going to notate this. So I'm going to call this leg A, or this vertex A, B, and C. And now I can notate the opposing angle here as little a. The opposing leg here from B is little b. And the opposing leg here is little c. So now we have some really useful notations because it directly correlates to our sine laws. So now let's work through this. So let's find theta, so the angle here, which remember we've also notated as angle A at this point. So just to help us kind of organize our work. Now at this point, we're solving for an angle. So put the angles on top. So here, sine A over little a is going to equal, and now we need to choose the angle that's given that has the opposing leg that's given. We would not use B here because we're not given this angle. So you'd have two unknowns and you couldn't solve for anything. So we're going to use the angle that's given with the opposing side length that's given. So we're going to use sine C over little c. And now we can plug in our notation. So angle A we know is theta. So sine theta. The opposing length was 2.2, which is A. That equals sine C. C was 86 over little c, which is 2.8. And now from here, we can solve our problem. So I'm going to multiply both sides by 2.2. So I get sine angle to equal sine, oh, that's a 2, sine 86 times 2.2 over 2.8. So let's just make sure everything's all good. Looks like it. So sine angle will equal sine 86 times 2.2 divided by 2.8. So that gives me 0.7838. Now recall, this is the ratio, not the angle. In order to find the angle, we are going to have to take the inverse of sine, 0.7838. And recall, we don't want to use a rounded value. So I'm going to use this whole value. So I'm going to press second sine, and then I'm going to press second and find my ants. Because remember, ants represents the answer that it was just solved for. Press the wrong button there. There we go. So I get my angle, or theta, to be 51.6098 degrees. So here, I have now found this angle. It wants us to, actually didn't tell us what to round to, so I'm going to round to the nearest degree here. So my angle will be 52 degrees. So this angle is 52 degrees. Now, we need to find the alpha angle, or angle B. You could go off and use all of this all over again. But honestly, that might be a bit of a waste of time because we have two angles in a triangle and we only need to solve for one. Remember, all of these angles add up to 180 degrees. So what I'm going to do here is I'm going to know that angle B, which equals alpha. To find alpha, I'm going to do 180 minus 86 degrees. And just note, I'm not going to round, I'm going to use the whole value. So I'm going to minus 51.6098 degrees. And here we have now solved for our angle. Let's quickly plug it in. So 180 minus 86 minus my last answer. So that gives me 42.39 degrees. And again, we're going to round to the nearest whole, so 42 degrees. And there's your solution. So I hope that was helpful, and I hope that all made sense. So remember, what am I solving for? What side length do I know that has the opposing angle given? Am I looking for an angle? If I am, put it on top. If I'm looking for a length, put it on the top. So there is your sine laws. So I would suggest going and practicing a few questions. Get this down pat, because the next bit can be a little confusing. We're going to talk about the ambiguous case. Other than that, if you have any questions, please come in and ask. Have a great day.